Hmm. Langsung. సార్ మీ వాయిస్ రావట్లేదు, అసలు ఏం వినిపించట్లేదు వాయిస్.
Second cross check.
ఓకే సార్.
Thank you, Santosh. Santosh, na? Screen పైన సంతోష్
sir, yes,
కనబడుతుంది. యా, థ్యాంక్ యూ అమ్మా.
Sir.
అంతకుముందు ఫస్ట్ ఎవరు హుషార్ అని వాళ్ళు కనెక్ట్ అయ్యారు. ఆమె అడిగాను ఎవరు ఇంకొక సమ్ అదర్ ప్రైవేట్ నంబర్ ఉంది 1013 అనేసి, వాళ్ళు కూడా చెప్పలేదు.
నాకు వినిపించలేదు
Okay.
సార్, అందుకే నాకు వినపడట్లేదు.
ఓకే, నేనే అడిగితే హుషార్ అనేది ఇప్పుడు మెసేజ్ ఇప్పుడు చూసుకున్నాను నేను. తీరి కదా అటు బోర్డ్ సైడ్ తిరిగి నేను ఎక్స్ప్లెయిన్ చేస్తున్నాను, అబ్జర్వ్ చేయలేదు. ఓకే,
అదే స్టార్టింగే వచ్చాను కానీ వినపడలేదు.
ఈజ్ ఇట్ ఓకే నో?
ఓకే సార్, ఓకే సార్.
ఓ మై గాడ్, అంటే ఇప్పుడు వరకు అంత బేసిక్ అంత పోయినట్టేనా? ఓకే, అక్కడ ఏం లేదు, జస్ట్ ఈ తర్వాత నేను చెప్పింది ఏంటంటే డిజిటల్ టు ఎనలాగ్ కన్వర్టర్ బేసిక్ స్టోరీ చెప్పాను, అంత రఫ్ స్టోరీ టెక్స్ట్ బుక్ లో ఉంది అక్కడ అంతా. అది బేసిక్ ఇంట్రడక్షన్ లాగా A to D సార్, డిజిటల్ టు ఎనలాగ్ ని కన్వర్షన్ ప్రాసెస్. ఇక్కడ డిజిటల్ టు ఎనలాగ్ కన్వర్షన్ ప్రాసెస్ బేసికలీ 3: అవుట్పుట్ ఆఫ్ కరెంట్, అవుట్పుట్ ఆఫ్ వోల్టేజ్, అవుట్పుట్ ఆఫ్ వేరియబుల్ వాల్యూస్. So in that conversion, first option I consider here, according to textbook order, variable resistor network. Variable resistor network convert digital data to analog data. And the blind చెప్పాలంటే digital is a binary లాగా, analog is a AC లాగా, direct current in analog current లాగా. So same like that, you can see the digital data converted into analog way. In the first one process is a variable resistor network. Second one R2R ladder network. So in that first one is a variable resistor network, DA converters. R, 2R, 4R, 8R. These resistors are connected in the parallel. These resistors output connected to operational amplifier. Op-amp connect చేస్తుంది. This terminal is common connection connected to operational amplifier. అంటే కామన్ కనెక్షన్ ఇక్కడ నుంచి తీసుకున్న కామన్ కనెక్షన్ దట్ ఈస్ కనెక్టెడ్ టు ఆపరేషనల్ యాంప్లిఫైర్. ఇక్కడ ఆపరేషన్ యాంప్లిఫైర్ లో మళ్ళీ ఇన్వర్టింగ్ ఆపరేషన్ యాంప్లిఫైర్, నాన్ ఇన్వర్టింగ్ అని వస్తుంది. పాజిటివ్ టెర్మినల్ ఈస్ కనెక్టెడ్ టు గ్రౌండ్ ఇస్తే ఇన్వర్టింగ్, నాన్ ఇన్వర్టింగ్ అన్నప్పుడు నెగటివ్ టెర్మినల్ వస్తుంది. One second. Okay. పాజిటివ్ టెర్మినల్ కనెక్టెడ్ టు గ్రౌండ్ అంటే ఎర్తింగ్ ఇస్తేనేమో ఇన్వర్టింగ్ ఆపరేషనల్ యాంప్లిఫైర్. ఈ సెకండ్ యూనిట్ లో వస్తుంది మనకి కంటిన్యూషన్. నాన్ ఇన్వర్టింగ్ అంటే నెగటివ్ టెర్మినల్ కనెక్టెడ్ టు గ్రౌండ్ ఇస్తేనేమో నాన్ ఇన్వర్టింగ్. రెండు ఆపరేషన్ యాంప్లిఫైర్స్ ఇక్కడ సింబల్ 741 IC తీసుకుంటాం. ఇన్వర్టింగ్, నాన్ ఇన్వర్టింగ్. పాజిటివ్ గ్రౌండ్ ఇస్తేనేమో ఇన్వర్టింగ్ ఆపరేషనల్ యాంప్లిఫైర్. It is non-inverting operational amplifier. This is a output connection terminal here. Next one is a operation amplifier ki bypass resistor, nothing but parallel resistor, feedback resistance. This is RF, feedback resistance, nothing but is a RF resistance. Okay. In this, we can take it as input digital data. In that, least significant bit, most significant bit. Okay, no? Maybe this is considered as a 0 or 1 digital values now. 0 or 1, 0 or 1, 0 or 1, 0 or 1, like that you can write. Look at 0, 1, 0, 1, 0, 1 connections. You can give individually or else common together. For example, I'm taking here 0 value. This is also 0. This is also 0. This is also 0. This all zeros connected to one common. This is battery with the help of battery. This is a ground symbol. This is a 0 on. Voltage here 0. Means for this one, for this one, 0 points. These are the 1 points. And they are 5 volt pin connection. This one is connected like the same thing. Here voltage of one, let's say here is a 0 volt, here is a 5 volt. Again, you can give the connections like this. Yeah. If you connect these two pins, least significant bit input data is a 0. If you connect upper one, this thing, that is will be 1. So you can take like a arrow. That arrow connecting a 0 pin now, 1 pin now, that is based on our choice. This is a 0, this is a 1. This is 0, this is a 1. These holes are connecting holes. Now I'm giving 0, 1, 0, 1, 0, 1. 0, 1, 0, 1. If you connect this arrow here, then here bit is a 1. If you're connecting arrow bottom, that is a 0, 1. Okay, now? This is a diagram. Now you can explain orally about the diagram. In variable resistor network, D to A converters, we are using 4 variable resistors. One is RO, 2RO, 4RO, 8R. It can look like 2 power 0, 2 power 1, 2 power 2, 2 power 3. Na? This is equivalent to 2 power 0 of 1. It will be get 2 power 1 into R. It can take 2 power 2 into R. It will be get 2 power 3 into R. The power of 2 on. That's our current paper. Here 4 variable resistors are connected in parallel. When if I give the input is a 4-bit data, in that purpose, number of required 4 variable resistors. In that one, ordering ascending connecting least significant bit is a 2 power 3 times half R. Most significant bit is a 2 power 0 into R. Nothing but R. Like such condition of way you can connect. Okay. Least significant bit is a final value. Most significant bit is a initial value. Understanding it? Least significant bit is a when you are going to increasing the variable resistor, the final value is a least significant bit. Starting value you can consider as a most significant bit. So that when in the input data, you can give in the form of either 0 or 1. You can give in the form of either 0 or 1. Like you can give connections. This next current flows across the RO, 2RO, 4RO, 8RO, and so on. How many resistors are considered that across that resistors current will flow. That current you can measure. Start from least significant bit data onwards. So here current is I'm feeling I0. Here current I can take a I1. Here current is a I2. Here current is a I3. Why I'm starting current here onwards means least significant bit data will be here na, so that's why I'm starting from here. I0, I1, I2, I3. 4 bits na 0 to 1 on. This is a current is here flows across the variable resistors. Now you can say this current can be converted into voltage by using operational amplifier. This current is converted into voltage by using operational amplifier, which will be the proportional to the digital input values. This current going to be converted into voltage. That voltage is proportional to digital input. Okay, now? This current is called as a weighted resistor DA converters, which current to I0, I1, I2, I3 is a weighted resistor DA converters. Okay. In that one, you can say the switches are used to connect. Which switches are these switches? These switches are used to connect digital either 0 or 1. These switches are connected used to either 0 or 1. When the 0 is connected, this is connected to 0 volt. When 1 is connected, that is a voltage is a 5 volt. That's what V of 1. That is a high voltage condition. Applying digital input, it can start from different conditions. Possibility. Input combinations, how many? 4 combinations. For so input terminals 4. 1, 2, 3, 4. Na? 4 means that combinations, it can come 16. Na? Here 4 input terminals are there, then output is 2 power n. Na? My bad. Input combination is, sorry. If n is equal to 4, if n is equal to 4, then input combinations is 2 power n, that is equal to 2 power 4 means 16 input combinations it can possible. Then you can proceed it same like yesterday type 8 zeros, 8 ones, 4 zeros, 4 1. That logic is there, no? In that way it can goes on in that way method on. Then the current, total current is, it can comes total current I is equal to, here 4 only na, that 4 input it can consist a 16 combinations. So from that I n minus 1 plus I n minus 2 plus I n minus 3 and so on up to I naught. Up to I naught. I3, I2, I1, I naught. Better you can take. I3 plus I2 plus I1 plus I naught. Like that total 16 combinations. That will be get a total input current values. Okay, na? From that you can calculate current across each resistor. Current across each resistor. This is nothing but 2 power n cube, like that, and so on, 2 power where it go up to 16 combinations. So in that you can calculate from the Ohm's law. We know here voltage is output, input is a current, mediator is a resistor. Relation between current, voltage, resistor, we know Ohm's law. V is equal to IR. From Ohm's law, you can use formula V equal to IR. So from that I is equal to V by R. I is equal to V by R. You can cross check current, this condition, current in this condition, and so on. So I n minus 1 is equal to V only, R value. This is I naught, I1, I2, I3, I4, and so on. In that condition, n last value is R only, na? So this is R. I n minus 2 will get V by 2R, and so on. Then I n minus 3, I n minus 4, and so on will be get conditions. N minus 1 this condition, n minus 2, n minus 3, n minus 4. Here 4 input, na? You can take that thing only. I n minus 3 equal to V by 4R. I n minus 4 V by 8R. It can be written as V by 2 power 0 into R, V by 2 power 1 into R, V by 2 power 2 into R, V by 2 power 3 into R, and so on. These are combinations. That all the values you can substitute in above conditions. Okay, na? If you put V is equal to 1 and the different conditions, you can cross check it. Then the total values you can substitute in that equation. Then we'll get a final equation. Then can I arrange space? Then I should rub this part. I'm removing diagram. You can continue that equation part. One second. ఇక్కడ ఏం లేదు, రాసింది మళ్ళీ రాస్తున్నాం, కొద్దిగా జాగ్రత్తగా అబ్జర్వ్ చేయండి. These values, sir, you can substitute in the initial values conditions. We know in the circuit diagram, here I0, I1, I2, I3 values. So from the diagram or from figure, I3 is equal to V by R, I2 is equal to V by 2R, I1 is equal to V by 4R, then I naught is equal to V by 8R. Okay, na? This value is the same that one all, na? V by 2 power 0 into R, V by 2 power 1 into R, V by 2 power 2 into R, V by 2 cube into, no, 2 power 3 into R, that values. Hmm. Yeah. Now we can find out output values when he given a condition is here. For a straight binary input, if V of 0 value means voltage of 0 is equal to consider as a 0 and voltage of 1, here 0 and 1 logic condition is there in the input condition, binary inputs. In that values, V of 1 is equal to, you can represent as a minus VR. The output voltage, then you can consider as output voltage is a V out, you can consider as a V naught. Then it can be written as output values, V naught is equal to minus VR. You can take it as common. That feedback resistance is a RF. RF by R into Bn minus 1 plus RF by, here 2 power 1 into R na. RF by 2 power 1 into R Bn minus 2 plus RF by 2 power 2 into R Bn minus 3 plus feedback resistance by input resistance, that is a 2 cube into R Bn minus 4 and so on, plus and so on, dot 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 dots. Up to, it should be get B naught. Bn minus 1 నుంచి B naught వరకు. N minus 1, N minus 2, N minus 3, N minus 4, N minus 6 and so on up to B naught వరకు. To the end of the conditions. Here you can consider as this minus into minus plus. Here you can assume VR is common, RF by R also common. So that term you can take it as common constant, that K he assumed here. K is equal to feedback resistance by input resistance R into 2 power n minus 1. Better connect first 2 power n minus 1. 2 power n minus 1 into R. Sorry. 1 by 2 power n minus 1 into RF by R. RF by R into this input common voltage VR. All the conditions here, if put n is equal to 1, then 1 minus 1 0. If n is equal to 2, this term, n is equal to 3, this term, n values you can goes on continuously, can substitute. Then in that condition, next step we can substitution of this constant value will get V naught is equal to, instead of that whole thing you can simply connect as a K. K into, will get, when you go that term, K into 2 power n minus 1 into 2 power n minus 1 into Bn minus 1 plus 2 power n minus 2 into Bn minus 2 plus and so on. It goes on up to B naught term only. Up to B naught. Here K is a here very variable constant, or else you can consider as a proportionality constant. Bn value is a 1, the nth bit digital input as a 1. If B naught consider as a 0, so Bn consider as a 0, the input digital data will be at 0 condition. You can stop here. If you don't get answer in the examination point of view, then you can write the figure diagram that first I1, I2, sorry, I0, I1, I2, I3 values, and you can give if input voltage V of 0 is equal 0, V of 1 is equal to VR, negative voltage, nothing but feedback voltage. Then V out is equal V naught. After that, you can write this equation, you can leave it. It can sufficient on. This is a variable resistor network. Variable resistor network means finally here converted input data is a current, output value is a voltage. Means digital current input to output analog voltage. That is a conversion thing on. Okay, next one is a ladder network with a resistor ladder network. I am feeling that ladder network is an examination point of view important comparing with variable resistor. The two methods, digital to analog conversion. One is a variable resistor network. Second one is a R2R ladder network. Means continuously use R and 2R values only from that resistor, so you can convert digital to analog. That is called as a R2R ladder network. That is the second process. First process is variable resistor, this one. Second process is R2R network only. Vasavi. Now am I audible? Someone Vasavi said still problem, voice problem.
Sir, I kept starting, sir, when you started.
Sir,
the
your
class.
voice is audible, but
No,
Okay.
now it's audible, sir. Starting, I
Okay.
post message in the
Okay.
chat box.
Okay. Thank you. Now, important thing is you can observe from your textbook, page number 271. There's a binary ladder, or simply they can mention R2R ladder network also. In the examination point of view, they can frame the questions in two ways: binary ladder network or else R2R ladder network. Okay, no? That thing is you can see once. A binary ladder nothing but is a known as a R2R ladder network. It is a superior, it's a easy and superior type of DA converter, which eliminates the various drawbacks suffered by the resistance divider type DA converters. In the variable resistor, we are dividing that current values, that problem rectified here, and only using of resistor changing or compressing. In that way only they are converting digital data to analog data. This is one advantages to comparing with of previous variable resistor network. So in this network, they will use only constructed of resistors only. That to be fixed values R and 2R resistors only. And that R and 2R resistors connected to input data 4-bit. 4-bit input data R2R networks they can connect, and which is connected through the operational amplifier, then we'll get output value analog only. So we'll see for that circuit diagram. So first resistance is, you can remember here, same like phase shift oscillator type. In the series R only, single resistance is connected. In the parallel, 2R resistors are network connected. Series way, one resistor. Like you can take first
sir,
4
excuse me,
resistors
sir.
connected. Yes, tell me.
సార్ మీ వాయిస్ క్లియర్ గానే ఉంది కానీ నెట్వర్క్ ప్రాపర్ గా ఉన్నట్టుగా లేదు. సడన్ గా స్టక్ అవుతుంది, మళ్ళీ రీకనెక్ట్ అవుతుంది, స్టక్ అవుతుంది. ఒకసారి చెక్ చేయండి సార్ ప్లీజ్.
This is a problem for everyone, only for once you can cross check remaining students.
Yes, sir.
This problem. Oh,
We can hear, sir, maybe.
obviously Hyderabad center location only Ramnagar. It is exactly between Hyderabad and Secunderabad center only. Geo fiber connections. From my side network, I'm telling. I am feeling from my side everything is okay. But anyhow, once you can cross check based on my knowledge, technical knowledge, once you can see your bandwidth colors, network bandwidth colors, you can say, Vasavi, okay, sir. Dear students, once you can check everyone your bandwidth color. అక్కడ నెట్వర్క్ వస్తుందా కలర్స్ ఏ కలర్ అని చెప్పగలుగుతారా
No, sir, it is the same as Santoshi and Anita told.
Okay. Otherwise, do one thing. Immediately you can remove and you can rejoin. Then we'll check it. Why? Because if I remove, then the meeting will be ended. I'm feeling. These are recording classes now. They won't consider my class. If you have to teach compulsory 1.5 hour. Once you can cross check, if won't get again that same problem. Mine fiber network okay. Vasavi okay. The next you can check. Immediately fraction of minute you can rejoin. After rejoining also, if you get same problem, I'll see last moment rejoin. If not that solve problem, then we can remove this meeting and again we will rejoin everyone. It's okay, sir. Clearly audible. Okay. Ooh, Vasavi. Okay. Next 221013. Okay, sir. Is it okay now?
Yes, sir.
Everyone.
Yes, sir.
If it is okay, I'll continue. Fine. Huh? Yeah, only 8 students are there. Participants are 8 members. 9 members join. Okay. You can leave myself and BRAU Hyderabad. That is a host. That is a recording person. Okay. Achyuta Kumari, Anita, Srilekha, Redmi Note 9, Suresh, Vasavi, and Xiaomi. Okay. This is attendance purpose. Okay, right. Okay, I'm feeling now a little bit better. Now that strength goes to 10 members. Okay, na? Now should I continue? Just you can communicate in a chatting box only. Yes. Thank you. Thank you, Achyuta Kumari. Yes, done. Simplest way. R2R network. 4 resistors connected in the series and 4 resistors connected in parallel. Parallel resistance values are 2R. Series resistor values are R. You can assume first that thing. Here 1 resistor, the next second resistor, third resistor, fourth resistor. Okay, na sir? Blindly. Easy to remember. Then next 4 resistors you can connect it in parallel. 4 resistors you can connect it in the parallel. One thing is 1, 2, 3, and in rougher. But actually resistance symbol is, I think you know in the school, college level on, intermediate college level on. This is exactly symbol of resistor. First one up, bottom, last one is the bottom to closing. Or else you can take vice versa. This is in the flow. I'm writing rough way only. It doesn't matter here. 4 resistors, no? In that 4 resistors, first you can give the parallel resistance values 2R, 2R, 2R. In that first you can take it is here R, R, R. And one more resistance you can take it as here parallel to this. 1. Yes. Then now we can give to the connections. We are giving input here. That input may be either digital input 0 or 1. So obviously you can take both 0, either 0 or 1. 0 or 1. The 0 or 1. 0 or 1. Yeah, connection you can give here. this pin connection like this pin same like in the previous condition type on. We took in the previous one is a diagram vertically, now I'm taking horizontally. Zero connection or one connection or zero connection or one connection. I can, sorry, here 1 0 1, it is a 0 1, and it connect just a 0, it connect just a 1. Again same like it is connected ground, voltage 0, which is connected to through the battery, it is a V of 1 volt. Then again here 0, V of 0. Again you can take it as same in the previous type only. This is a ground V of 1. Story you can do fast. అంటే కంపేరింగ్ ఒకసారి చేస్తే రెండోది కూడా ఈజీగా గుర్తునేటట్టుగా మీకు వేలో డయాగ్రామ్ ప్రాక్టీస్ చేయండి. యూ హ్యావ్ టు డూ యువర్ సెల్ఫ్ ప్రాక్టీస్. ఓకే, దిస్ ఇస్ ఎ గ్రౌండ్, సో ఇట్ ఈస్ ఎ V of 0 and this is a plus minus, again it is a V of 1, V of 1, right? If you connect here 0 1, that logic digital input values. Okay, fine. Now you can take the terminals A, B, C, D, whatever may be names, junctions. The resultant of these two values, if these two resistors are obviously looking in the parallel only, no? If the resistors are connected in the parallel, the effective resistance value is reciprocal addition. No? We know the condition. RS, series condition, direct addition of resistance values. In the parallel condition, reciprocal addition. That 1 by Rp is equal to 1 by Rp is equal to 1 by R1 plus 1 by R2. That is nothing but Rp is equal to product by summation only R1 R2 by R1 plus R2. It is a basic knowledge. అంటే బేసిక్గా ప్యారలల్ ఉంటే రెసిప్రోకల్ అడిషన్ చేయాలి, సిరీస్లో ఉంటే డైరెక్ట్ అడిషన్ చేయాలి. సో దీస్ టూ ఆర్ ప్యారలల్, 1 by 2R plus 1 by 2R. Obviously we'll get R only. This R again finalize 2, అంటే ఇది రిమూవ్ అయిపోయిన తర్వాత affected value will get R only. I'm doing directly here. Affected value will get here R only. Previously 2R connected in the parallel, that affected value goes to R only. After that, now you can these two are in series or parallel. How can I predict series and parallel? If the current is remain same, you can say the series. If current is dividing, you can say the parallel. ఒకే లైన్ కి కంటిన్యూగా ఉంటేనేమో సిరీస్, ఇలా డివైడ్ అయిపోతేనేమో ప్యారలల్. లేదా అకార్డింగ్ టు ఫిజిక్స్ వే, if current is remain constant, you can say the series. If current is dividing, you can say the parallel. And this is R plus R, 2R. These 2R affected value is a 2R. These 2R and 2R again in parallel. You have to redraw the diagram. One simplification, once again diagram. First diagram ikkada ఇప్పుడు నేను ఎరేజ్ చేసింది ఒక కేసులో వస్తుంది. Again once again you can draw the diagram. This is a rough, no need. Okay na? Here the thing is connection connected to operational amplifier na. This is connected to operational amplifier, inverting operational amplifier, and that is connected to output. Here V0 output, and here is a feedback resistance, same like in the previous condition lo ela aitundo same diagram అక్కడ ప్రీవియస్ కండిషన్ 4 వేరియబుల్ రెసిస్టెన్స్ ప్యారలల్ తీసుకొని వాటి నుంచి డైరెక్ట్ గా ఆపరేషన్ యాంప్లిఫైర్ ఇచ్చాం. ఇక్కడ ఏం చేశాను, రెసిస్టర్స్ ని R 2R రెసిస్టర్స్ ని ఫ్యూ ఆర్ ఇన్ సిరీస్, ఫ్యూ ఆర్ ఇన్ ప్యారలల్ లో కనెక్ట్ చేసి ఒక దగ్గర నుంచి కంప్రెస్ చేసుకుంటూ వస్తున్నాను ద డేటా. ఫస్ట్ కండిషన్స్ 2R in parallel, that affected value we got R only. That R and R again series, that affected value will get 2R. These 2R again, these 2R again it comes in parallel, that affected value will get R. That R and this R again in series, again 2R. The 2R, these 2R again will in parallel, that again affected value will get R. That R and this R again it comes in series. Understanding my logic? ఏం లేదు, రెండు ప్యారలల్ లో తీసుకుంటే R వచ్చింది, అది వచ్చిన R వాల్యూ ప్రీవియస్ ఇక్కడున్న R తో కంపేర్ చేస్తే సిరీస్ లో అవుతుంది, ఆ రెండు ఎఫెక్టెడ్ వాల్యూ 2R అవుతుంది. ఆ 2R మళ్ళీ ఈ 2R ప్యారలల్ వస్తుంది, మళ్ళీ R 2R సిరీస్ ప్యారలల్ ఎక్స్టెండ్ చేస్తుంది. హియర్ ఫైనల్లీ ఐ కెన్ చెక్ అంటే ఇక్కడ వరకు వస్తుంది 2R, ఇక్కడ R. ఈ 2R affected value will get here 2R. The 2R, these 2R again will get R. R ఇక్కడ sufficient గా 2R this. Understood? 1 minute you can cross check the diagram here and your textbook diagram. You can compare it. It will be easy only. But I am explaining in the one diagram all 4 steps. But you have to do yourself one step, again repetition diagram. First step, R to R parallel condition. Next step, that affected value you can take it as R. This R and R in series will get 2R. Up to goes on continuously decreasing of the circuit diagrams. Given 2A, 2B, 2C, like 2D, the conditions are given. That affected value you can consider. That compressing of resistance values okay na? Parallel lo ఉన్నప్పుడు reciprocal addition, series lo ఉన్నప్పుడు direct additions. Is it clear? When the resistors are in parallel, you can take it as reciprocal addition of that values. When the resistors are connected in series, then you can consider as a direct addition values only. After that, finally, the final value you can consider as affected value, output values. In that condition, finally you can take it as affected value as voltage dividing rule, sir. If you want to find the effective resistance across this point, and the point diagram ni, again I'm taking previous step. We'll go 1, 2, 3. Here we'll get 2R. This junction I'm feeling is A. Here is a 1 resistor is there, no? 1 resistor R on the first diagram. Okay, na? At this junction, you can find out voltage. VA is equal question mark. You can observe at that from the circuit diagram, I'm going to finding voltage at a point A. VA is equal to voltage across this resistor is a VR into output resistance is a 2R by parallel affected resistance is a R1 plus R2 type on. So that value again, both are in the parallel, then 2R plus 2R. Then you can simplify this value, we'll get something. You can take common 2 get can cancel. Then R by 2R, it can get V voltage across the R resistor into R by 2R. Again, this RR will get cancelled. Then we'll get finally voltage at point A is equal to VR by across the R resistance. VR by 2. Voltage across the R resistor, that is a VR by 2. Voltage across the 2R resistance, then we'll get a V2R by 4. It can dividing that values on. Again, the input signals, you can give it as, again, same like 16 combinations. Na? In that combinations, you can consider as 8 zeros, 8 ones, like that table form only. But you can say the voltage the first resistor is VR by 2, across the second resistor VR by 4, next third resistor VR by 8, VR by 16, VR by 32, and so on. It can goes on continuously end up the resistance values. Okay, na? Voltage at point A, voltage point B, voltage point C, voltage point D. So this value will be get VB. So VR by 4 VC. Better you can take junctions. At that point, voltage VC VR by 8 VD VR by 16. But you should get one doubt here. Voltage always we can consider across the 2 points. So how we are telling here at particular point means one terminal is here B, another terminal is ground 0 only. Means VB minus VB minus V0. Understanding? Always voltage, nothing but potential difference measuring across the 2 points. Current particular point, but voltage measuring always across the 2 points. One point is here A, B, C, D respectively. Another point is fixed the ground only between like this. Okay, na? So that value you can take it as V net is equal to VA plus VB plus VC plus VD. That values you can add and you can leave it. Is it clear? Then done. This is a R2R ladder, but you have to do step by step compressing resistance values, and you can redraw the at least 3 compressing diagrams. And if we eliminate చేసి ఇక్కడ parallel resistance eliminate చేసి series లో వచ్చిన resistance సో దాంతో కంటిన్యూ అయ్యాక 3 to 4 steps లో re-diagram draw చేస్తే will get easily, and you can express the voltage across A, across B, across C, across D. Then V net is equal to, you can say, VA plus VB plus VC plus VD. Then you can stop there. Is it okay? Right. But it's an examination point of view for 10 markers. R2R ladder network, 70% weightage, 30% I'm feeling variable resistor network. These two. Why? Because in this block, only 2 units are there. That to be less number of questions, only selected question they are repeating. Okay. ఎల్లికి అడుగుతున్నామో ఈ వేరియబుల్ రెసిస్టర్ నెట్వర్క్ లో ఏదో ఒకటి అడగొచ్చు. వేరియబుల్ రెసిస్టర్ అన్నా R2R అన్నా, అది మిస్ అయితే ఎస్ఏక్యూలో నెక్స్ట్ వన్ ఇస్ దేర్. వెరీ వెరీ ఇంపార్టెంట్ థింగ్ ఫ్రమ్ యువర్ టెక్స్ట్ బుక్ పేజ్ నెంబర్ 276. Resolution and accuracy, linearity. Okay, these 3 are very very important. Once you can observe from your material, page number 276, resolution. It is a very 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 important thing in short answer questions. Okay, now they can ask what is a resolution, you can explain. They will ask like that questions only. The resolution capability determines the smallest change in the analog input, which can be discriminated by digital to analog converter. A converter which can accommodate large number of bits will have a better resolution than one which accommodates a smaller number of bits. Understood? For example, 10 bits will have 2 power 10. అంటే 1024, 1 GB అంటాం జనరల్గా మనం. 1 GB is nothing but 1024 MB only now. So 102 instance of stand that they can express in terms of 1024, they can say simply 2 power 10 only. Conversion things. Analog లో అయితేనేమో 1024, digital అయితేనేమో 2 power 10 లా కన్వర్ట్ చేస్తారు. The smallest change which it can detect will be 1 by 1024 of the full scale output. This converts has a resolution of 1 part of 1024. That resolution it can express in terms of percentage. 1 by 1024 into 100. Then it can get the value 0.1% can changing value. Understood? Theory only. Once you can read carefully, try to understand. Next, one more 5-mark question, SAQ. Accuracy. Next one. The accuracy of the digital to analog converter is primarily a function of the accuracy of precision resistors used in the ladder and the precision of the reference voltage supply used. కాకపోతే ఇది ఎగ్జామినేషన్ పాయింట్ ఆఫ్ లో గుర్తుంచుకోవడం లిటిల్ బిట్ కాంప్లికేటెడ్. బెటర్ యూ కెన్ గో త్రూ ఇట్ అనదర్ వే స్టేట్మెంట్స్. ఇవేని ఇదే టర్మినాలజీతో ఎక్స్ప్లెయిన్ చేయాలంటే కొద్ది కష్టం. సో దట్స్ వై బెటర్ యూ కెన్ గో త్రూ ఇట్ accuracy definition in another way. Means generally accuracy means what? This is their precision and accuracy terminology in the low grades. Accuracy means exact acute value అంటే దగ్గర క్లోజ్ ఉన్న వాల్యూ కదా. ఫర్ ఎగ్జాంపుల్ G value 9.8. After doing our lab experiments, if we get the value closer to the 9.8, then we'll say how much accurate. We'll say the how much accurate to the original value. Then you can say the in another way, note down how close a measurement is to the true or actual or accepted value. Once again, how close to measure or measurement value is to the true value or true value or accepted value. That is called as simply you can say accuracy. If it is okay Telugu language, then you can proceed. అంటే మనం కనుక్కున్న వాల్యూ యాక్చువల్ వాల్యూకి ఎంత క్లోజ్ గా ఉందో చెప్పడం యాక్యురసీగా ఉందంట. రియల్ వాల్యూకి క్లోజ్ గా ఉన్న వాల్యూ దట్ విల్ సే యాక్యురసీ థింగ్ ఇస్ ఓన్. ఓకేనా? In that way you can remember. Given in the next third line, it is a specific accurate. Second line, accuracy is measured of how close the actual output voltage is the theoretical output value. That word is important. Okay na? All right, so then enough. This unit is enough. So in this unit you can see once examination point of view important questions. Second bit, third question, very important. What is the difference between resolution and accuracy? This is a repeated question I saw in the previous papers. Next, second question. What are some of the advantages of binary ladder over the resistive ladder? How is a binary equivalent weight determined? Describe how to the output voltage resistor is divider. No. Voltage divider. First section lo first question సెకండ్ సెక్షన్ లో సెకండ్ అండ్ థర్డ్. ఓకేనా? దెన్ డన్. next unit, that is the last unit in this block, 22. Now you can go to next unit number 22. Now reverse, analog to digital conversion, D to A over next to A to D, analog to digital, converters. One second, we'll see here. We can simply remember same mux, demux, same type here, digital to analog, analog to digital. Previous one is a digital conversion, digital data to analog data conversion. Now you can assume as analog data converted into digital. Okay, na? The process of changing analog signal into digital signal, that process is called as A to D converters. Okay, first one you can consider as a analog to digital converter theory part. Okay, the basic introduction part. A to D conversion is a quantizing process. An analog signal is represented by equivalent binary states. This is the operate to the digital to analog conversion process. Analog to digital converters can be classified into two general groups based on the conversion techniques. Here also two basic conversions. In the previous also, D to A analog conversions also two methods. One is we know variable resistor method. Second one, R to R ladder network, digital data converted to analog data. So here also they're saying analog data converted into digital data, two general groups techniques. One technical involves comparing the given analog signal with a internally generated equivalent signal. That is nothing but flash type converters. Another technique, changing an analog signal into time or frequency, comparing these new parameters to know the values. One is initially generated equivalent, that is an analog signal converted to digital, comparing values. Other one is a flash type converters. Second one is a flash type converters. First one is a comparing given data values, then generate the equivalent output value. So basically, simply you can say the first method is comparing method. Second method is flash type converters. These two methods, analog data converted into digital data. Okay. So in that, first basic term is, one more thing is 4-mark question, quantization. I think you know quantization of charge. Quantization of charge is reflected in electronics. Quantization means the fundamental value which is multiplied with integer number. According to the electricity, charge based thing is quantized. For example, total charge of the thing is Q, which is equivalent to integral multiple of fundamental charge of either electron or proton. If you consider proton, you can consider as a positive charge. If you consider as a fundamental charge is electron, then you can take a sign is negative. That is called as a Ne. We can say here charge is quantized. Charge is quantized. This thing is Q is equal to plus or minus Ne, where N is an integer number 1, 2, 3, 4, 5, 6, and so on. E is a charge of the particle. Which part? The fundamental charge particle, either proton or electron. If you consider positive particle, then you can say the proton charge. Proton charge, electron charge, both are same. Only sign is different. For proton is a plus 1.6 into 10 to the power of minus 19. For electron is a minus 1.6 into 10 to the power of 19. Both the units are coulombs on. Okay, now like that. Here quantization, quantized. Charge quantized, here signal quantized. This is important in the 4 marks. Maybe they can ask, explain the quantization things. What is quantization? They'll ask in the 5 markers. You can underline or you can go through it in your book, page number 280. In a 3-bit digital to analog converter, there are 8 possible input states. Yeah, obviously we know. If 3 inputs, combination is 8. If 4 inputs, combination is 16. If 2 inputs, combination is 4. For example, he is assuming is a 3 input terminals. In that is possible number of digital inputs are fixed. అంతే కదా, ఇన్పుట్స్ అనేది తీసుకుంటే దాని పాసిబుల్ నంబర్స్ ఆబ్వియస్లీ ఫిక్స్డ్ గా ఉంటాయి. In construct in a analog to digital converter, analog input can have any value, but the number of digital output are fixed for a given analog to digital converter. For an n-bit analog to digital converter has 2 power n discrete. అంటే n ఇన్పుట్ టెర్మినల్స్ ఉంటే దాని కాంబినేషన్స్ 2 power n కదా చెప్పేది. అదే n ఇన్పుట్ n bit input analog to digital converter has 2 power n discrete channels or discrete levels. Therefore, a given analog voltage is required to be represented only in 2 power n intervals. అంటే ఎన్ని ఇన్పుట్స్ ఉంటే అంత 2 power వస్తుంది కదా కాంబినేషన్ పాసిబుల్, అంటే ఇన్పుట్ కాంబినేషన్ పాసిబిలిటీస్. This process of dividing an analog voltage based on number of bits, 2 bits datana, 3 bits datana, 4 bits datana, otherwise 8 bit datana, 16 bit datana. Based on that input voltage number of bits, digital is known as quantization. అంతే కదా, అక్కడ నేను ఛార్జ్కి ఏం చేసుకున్నాను, ఇంటీజర్ నంబర్ 1, 2, 3, 4, 5, 6 అండ్ సో ఆన్, అంటే ఎన్ని ఛార్జ్ పార్టికల్స్ ఉన్నాయని. ఇక్కడ ఏం చేస్తున్నాడు, ఆ ఫండమెంటల్ వాల్యూస్ కి దేంతో మల్టిప్లై చేస్తున్నాడు, ఇన్పుట్ కాంబినేషన్స్ ఎన్ని ఇస్తున్నాను దాంతో మల్టిప్లైయింగ్. దట్ ఇస్ కాల్డ్ సింప్లీ కెన్ సే ద క్వాంటైజేషన్ ఆర్ క్వాంటైజ్డ్. Quantization. Each interval is given a n-bit binary code, which is referred as encoding. Oh, new word, encoding, decoding. Encoding, many input to one output. That's the encoding. Decoding, one to many. అంటే ఒకటే వర్డ్ ఉంటుంది కానీ మీనింగ్ చాలా వస్తుంది దాంట్లో. డీకోడింగ్ జనరల్ గా అంటాం మనం, పెద్ద లార్జ్ డేటాని సింపుల్ గా తీసుకోవడం డీకోడింగ్ లాంగ్వేజ్. ఎన్కోడింగ్, డీకోడింగ్స్. దిస్ ఎన్కోడింగ్ సిమిలర్ టు ద మక్స్, డీకోడింగ్ సిమిలర్ టు ద డీమక్స్. మెనీ టు వన్ ఈజ్ ఎన్కోడింగ్, one to many is a decoding language. Consider an analog voltage from 0 volt converted into 3-bit digital output, that is any voltage in this range represented as 3-bit digital output. In that condition, if we consider 3-bit data, the voltage it can divide. Possible conditions is, how many combinations are possible? 8 combinations. So for each combination, it can divide by V by 8, V by 8, V by 8, V by 8, V by 8 only. That V by 8 conditions, it can splitting. So for example, you can say the possible combinations. If input terminals are bits, consider as 3, then combination it can comes 8 combinations. Na? In that 8 combinations, you can consider as least significant bit, most significant bit, any order. So 1, 1, 1, 1, 0, 0, 0, 0. Then 0, 0, 1, 1, no, 1, 1, 0, 0. 1, 1, 0, 0, 1, 1, 0, 0. Then we'll get 0, 1, 0, 1, 0.
No.
Sir is not there.
Hello.
Hello.
Yeah. Yes. Is it okay now?
Yes, sir.
Thank you. No, what I'm saying here, it is the least significant bit in 3-bit variable data. 8 input combinations are possible. You can take up to bottom or bottom to, so top to bottom, bottom to top, and the bottom will be reverse order. Least significant bit, which is the most significant bit, MSB. If the 3 bit input data, in that one interval, the voltage it can classify into 8, 1 by 8. So here 1 by 8, 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 like that 8 times 1 by 8, you'll get finally voltage V only. That input V voltage, it can classify divided into 1 by 8 times each the conditions. The voltage range in the 1 clock pulse, the voltage it can divide by 8. So V by 8 plus V by 8, 2V by 8. Again 2V by 8 plus V by 8, that is a 3V by 8, 4V by 8, 5V by 8, 6V by 8, 7V by 8. Okay, na? Next one is this is comparing our combinations of inputting process conversion A to D. Next method, very, very important method, that is a flash analog to digital converter. That thing definitely can expect in the exam for 10 marker purpose. Or else, if by chance miss that thing, you can expect DL slope analog to digital converter. Or else one more also there, successive approximation analog to digital converter. These 3 questions are important questions. Conversion of AC to digital. Okay, we'll take now first flash AD converters. Flash AD converters. జస్ట్ మినిట్ ఒక్కసారి మీరు చూడగలిగితే మీకు ఏమన్నా ఓన్గా చేసుకోగలిగితే నేను స్కిప్ చేసి ఇంకోటి చెప్పగలుగుతాను. అదర్వైజ్ హ్యావ్ టు ఎక్స్ప్లెయిన్ one by one. Yeah, your time is obviously so less time, 10-15 minutes time only. Na? We'll see first flash AD converters, then based on the time we'll see it. Important 10 mark question. Second method, flash converters, flash A to D converters. A to D converters. Analog to digital converter. Okay, no? In that converter, you can use resistor and operational amplifiers. Resistor and operational amplifiers. You can take one resistor. Resistor nothing but a group of flip-flops only, na? Okay. For that one input connection, I can consider as a operational amplifiers. 7 operational amplifiers you can consider. 1, 2, better you can take in smaller size. Try to understand 1, 2, 3, 4, 5, 6, 7 operation amplifier. These 7 can connected to registers. This is the input of C1, C2, C3, C4, C5, C6, C7. Okay, na? Analog voltage and reference voltage. 2 voltage you can consider here. One thing is analog voltage, positive terminal, V analog. A plus minus also there now. Inverting operational amplifier. Plus or minus, that's fine. And other pin is connected to reference voltage. reference voltage term here we can take the simply VR. This VR is connected across the resistance. First one is the resistance here is a R by 2. Then you can connect the terminals. First one. This is the second, third, fourth, fifth, sixth, seventh. One input output. ఒక్కో దానికి మధ్యలో రెసిస్టెన్స్ R. 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 Like that, all the resistors like this connections. Okay. One is a reference voltage, other one is an analog voltage. These are the connected to the input terminals. Input terminals. So that is dividing part. That is connected to resistor. Again, the resistor, it can clearing purpose. You can take is a that changing the clock pulses. You can take the clock connection here, and which is connected to 8-line to 3-line encoder. Encoder 8 to 3-line encoder. Which is converted into 3 lines output. 7 to 3 lines encoding. In that one, least significant bit here LSB, MSB. LSB, MSB. Binary codes output or digital output we can take in the, better I can take analog to digital na, digital output. Digital, this is the output. Least significant data, most significant data, and this one is a register. And this is a 8-bit to 3-bit line converter, or 8-line to 3-line converter. Then you can take a 8-line means here how many there? 8 lines there, no? 1, 2, 3, 4, 5, 6, 7 only. Better you can take one more 8 lines. Plus minus, again same story only. And 8 to 3. 8-line data converted into 3-line data. Analog to digital, that is a conversion things on. Okay, na? So for that purpose, we have to take it as comparator output values. These are comparator output values. And then next we can consider as a digital output values. These comparator output values we can take in the tabular form, and that values we can consider as a digital output values. Obviously that digital output values will be easy. That is, we can assume as one is a B0, this is a B1, which is considered as a B2. These are the comparator output values here. Comparator output values are here. That comparator output values we can consider as a combinations. Then we can take it as digital output data. So digital output will be get 3 variables now. So sorry, three input. My bad. 3 terminals. Then we'll get 8 combinations. In that 8 combinations, zeros and ones you will get easily. So for that purpose, first we can take it as output. Output digital. 3-bit digital data. Digital data. B2, B1, B0, or B0, B1, B2, whatever maybe. In which way we can consider, in that way we will get answer. So we'll get here 1, 2, 3, 4, 1, 2, 3, 4. Then we'll get 0, 0, 0, 0, 0, 1, 1, 0, 0, 1, 1, then 0 1 0 1 0 1 0 1. This is a clear, okay, output data. Then now we can cross check here. Comparator, this input terminals we are giving here, output of comparator. That output of comparator giving to the register, that register values again you can taking and the 8-line to 3-line output. That purpose comparator output values from C0 to C7 or C1 to C7. C1 to C7. C indicates here comparator 1, comparator 2, comparator 3, comparator 4, like that. That comparator values, blindly you can go Pythagoras theorem. ట్రయాంగిల్ షేప్ లో వస్తుందో అని అంటారు పైథాగరస్ థియరీ కదా ఈ బాక్స్ లో. అంటే ఈ లైన్ లో ఈ జీరోస్ డిక్రీజింగ్ ఇంక్రీజింగ్ ఆర్డర్ లో ట్రయాంగిల్ షేప్ లో దట్ వాల్యూస్ ఇట్ కెన్ గోస్ ఇంక్రీజింగ్ అండ్ డిక్రీజింగ్ మెథడ్ టైప్ ఓన్లీ. అంటే యూ విల్ గెట్ హియర్ ఆల్ ఫస్ట్ జీరోస్ హౌ మెనీ C1 C2 C3 C4 C5 C6 C7 4 5 6 7. Then you can reduce 1 1 zeros 0 0 0 0 0. Then you'll get 0 0 0 0 0. Then you can get here 0 0 0 0. Then furtherly 0 0 0. Then reduce the steps on like here 0 0. Then you'll get 0. Then the rest of the part here 1, here 2 ones, here 3 ones, then here 4 ones, then here 5 ones. Then you can take here 6 ones. Then finally you can take it as all ones. I'm doing very confusedly here. You can check once your textbook and you can try to understand that these are the comparator output values. First data will be get all the combinations. C7 value will be all zeros only. Second one, once last data will be 1 C1 value 1 combinations. That comparator outputs analog to digital. Analog to digital comparing thing only. Okay now? Then one more. The next you can see from your for yourself dual slope AD converter. Then next last one, successive approximation A to D converter. It is also repeated so many times in 10 markers. Successive approximation A to D converters. Same like in the this condition type only. Once you can check theoretical part only. Block diagram of successive approximation type of A to D converter as shown in the figure. In that one 8-bit to 8-bit digital to analog converter. Analog to digital, then digital to analog things on. 8-bit successive approximation analog to digital converter requires 8 clock pulses. 8 clock pulses. So in that one, comparisons, comparators not required. Comparator nothing but non-inverting operation amplifier only. So the data is given here. Once you can check in the diagram in your textbook, page number 288. Input value analog voltage through across one comparator. The ruling voltage it can gradually increases with the 8 different clock pulsative. With the 8 different clock pulsative, 8-bit register in that one, D0, D1, D2, D3, D4, D5 and so on. That values are connection in that one. In that every intermediate stage, you can give the clock pulse. Every intermediate state, you can give the clock pulse and you can reset 0 to high. In that condition, you can check in the diagram. The theoretical part is there now. Once you can see. 8-bit successive approximation register, successive approximation register. That one is given the diagram SAR. 8-bit SAR means 8-bit successive approximation register, which can convert analog data into digital. Okay, now the start of conversion cycle, signal kept high voltage always in every clock pulse. It can reset the successive approximation register. Always you can consider as a 1 high voltage type one. If the comparator output is high, digital to analog or that voltage value will be lesser than to analog to digital. The output comparator is serial data feed into the 8-bit register. Once you can read that story part from the book, but it will be useful and important only. It is repeating. If not understood, you can let me know in the next class. We'll see, but we'll stop here only. Is it okay, dear students? Once you can go through it, successive approximation A to D converter from your textbook. And one more important note is we have 2 more weeks, official weeks. This coming Saturday, Sunday, and next coming Saturday, Sunday. In that weeks, next I'll start second block. After finishing up second block, then based on our comfortable time, we can go back to first unit. From the university side, we have 4 more classes officially. After finishing up that 4 more classes, official classes, if your side required any class, if we can take extra classes. That is based on your choice. If you required, you can message or you can intimate me in the last class. Then I can plan based on your convenient time in the evening hours, like 7, 6, after 6 only basically. All days we can plan the day types. But our exams are August 9th now. So mostly they are finishing schedule next 2 weeks. Means July 2nd week, it can going to finishing official classes schedule. Then July 2nd, 3rd week to July 4th week. The 2 weeks that time is there now. In that 2 weeks, if you required, we can take the class back to which parts you are feeling tough. That thing we can once again discuss in the online mode. Is it okay? Yeah. Now tell me any suggestions from your side. If anything are there, we can rectify it. We can try to change it. So this is a blog post story. In the next more, I'll try to send important questions in the WhatsApp group. Once you can go through it, that questions also based on your convenient time. Now I'm sharing now only in that WhatsApp group. Block wise, just I prepared selected questions. Means based on the previous question paper, I prepared as a small thing. That questions is sufficient. For exam point of view, I already shared in that WhatsApp group. Once you can see block wise. Block 1 and block 2 important questions. Unit number, page number, section 1, section 2 also there now. In that one, section 1, section 2, question numbers. Am I clear? Block 1, block 2, next block 3, block 4. Unit wise, page number, section number, question number. If any changes in the new printing books, I didn't see new printed books. There's a 7-8-year-old book I have. In that book only, I took page numbers. If any changes, please let me know. That page numbers, I'll modify that things. If any confuse in that questions, you can let me know. Then I'll proceed it. Is it clear? Yeah, I'm stopping here only today class. The next coming Saturday, we can plan. Thank you, Achita Kumar. We can plan next Saturday, Sunday, that second block target. If possible, I'll try to finish as soon as possible early second block in hardly 2 days, Saturday and Sunday if possible. Mostly it's complicated only, we'll try. If it is done that coming Saturday, Sunday block 2, then next 2 days, Saturday and Sunday, we'll go back to first unit. Okay, now? So before that, you can pre-planly, you can go through these selected questions only. First, you can try to finish. After that, your wish. అంటే వేరే చదవడం కాదు, ఈ కంపల్సరీ చేశాక నెక్స్ట్ క్వశ్చన్స్ యూ కెన్ గో త్రూ ఇట్. Is it okay? Right. Then we can stop here only. Then next we'll meet coming Saturday. Before that, if any doubts, you can message to my WhatsApp number. But you can start from your side preparation. Hardly 1 month only time. This June month is over, July month 1 month only. So in that month, you can try to pre-plan all the blocks. Okay, bye. I'm leaving here only.
Thank you, sir.
Okay.